MPLS semi-dynamic tunnel with loose next hop. In this video, I'm going to talk about again semi-dynamic tunnel pass option, and now I'm going to talk about the loose next hop. You know that in previous video, we talked about the semi-dynamic pass option with the exclude address, okay? And you learned about the configuration of that type of the semi-dynamic tunnels. Now I'm going to talk about another type of semi-dynamic tunnel, loose next hop. What is the loose next hop? What is the usage of the loose next hop, and how we can configure the loose next hop? Let me to talk about the loose next hop semi-dynamic tunnel in this scenario. As you can see here, we have R1, R2, R3, R4, and R5, and between the router 3 and router 4, we have, for example, 2 paths or 2 links. You know that when we are configuring explicit paths, we need to configure the next addresses or next hops that the tunnel should pass from that, for example, routers. And also when we are configuring dynamic tunnel, we can say, hey, teeth or traffic engineering, you can select the paths with the, for example, desired with the compatible parameters with the configuration of the interface tunnel. But in this type of, in the semi-dynamic tunnel, we don't want to configure explicitly the paths, and we don't want to configure or we don't want to dynamically selecting the paths. We need to use a method between the explicit and also dynamic, or in this method we are combining the explicit and also dynamic. Let me to talk about the semi-dynamic next hop. Look at here. Assume that in this scenario, we have 2 paths from the router 1 to router 5, okay? And we need to use the, for example, lower paths for reaching to the destination. You know that in this scenario, okay, we are using ISIS, and ISIS by default uses the metric of, calculate the metric of every pass with the cost of interface, total cost of interfaces in that pass, and the default value of the cost or metric for every interface in ISIS is 10. Because of that, from the top pass R1 to R2 to, for example, R5, for example, a loopback 0 on the router 5, okay, we have the metric of the 30, okay, because here we have 3 links, R1 to R2, R2 to R5, and R5 loopback 0, okay. And in the bottom pass, when we need to go from R1 to R3, and then, for example, R4 and then R5 loopback 0, we have one, for example, link, for example, more than the higher pass, and here we have the metric of 40. Because of that, according to the IGP metric, the best pass is the higher pass, okay? When you are configuring one interface tunnel, okay, and for example, in that interface tunnel, you are configuring the dynamic pass option. If you configure dynamic, automatically R1 chooses the higher pass, R1 to R2 to R5, because this pass, for example, is a best pass, and also about the hop count. In this pass we have the only 2 hop count, and in the lower pass we have 3 hop count, and because of that the higher pass is better. And also, if you want to change this default behavior in the explicit method or static method, you can configure the explicit method with only specifying the next hop. For example, in the previous scenario, when we had only one link between the R3 and R4, we can configure these next stops. The first next stop is 10133, router 3. The second next stop is 10344, okay? And after that, the third next stop is the 10455, okay? But here we have a problem. Assume that I'm not going to use the dynamic method. and I'm going to use the explicit method, and I need to use the bottom pass for tunnel. Okay, here we have a problem between the router 3 and router 4. We have two links, and how we can configure explicit pass, that in this explicit pass we can use both of these paths. For example, assume that between the router 3, okay, and router 4 we have two links. The first link's subnet is 10340, okay, 10340/24, and the bottom link subnet is 10430/24. Okay, this means that now we have two paths between the router 3 and router 4, and in the explicit path we can configure only one next hop in this link, and if you configure one next hop, as a result you will use only one of these paths, but we need to use both of them. Okay, how we can configure the for example explicit path from the bottom path, and after that we use the, for example, both of this link. In the normal explicit path you can't configure more than next hop in this in the subnet between the router 3 and router 4, in the between the router 3 and router 4. And here we have a problem. Dynamic method is not suitable for us because we need to select the bottom pass, and in explicit method configuration we have a problem here. Maybe here we have more than one link, for example 3 links, 4 links. How we can use these links according or dynamically? You know that here we have two, for example, exactly same path. Maybe the metric of this path is different, and you need to use the best metric or best cost. After the best cost link failed, you can use the other link. How we can configure it? The answer is that we can configure semi-dynamic. Okay, semi-dynamic tunnel. In semi-dynamic tunnel we have one option, we call it loose next hop. Assume that we are configuring the explicit path. Okay, in explicit path we can configure the next hop of the 10133 as a strict next hop. A strict next hop means only 10133 is acceptable. Okay, after the first strict next hop we can configure for example the other next hop to reaching to the for example router 4. Assume that in router 4 we have one loopback IP address 192.168.2544. We can configure the next hop 192.168.2544, but this is the loose next hop. What is the loose next hop? This means that this next hop can or should be reached, but the path to reaching this next hop is not important. For example, maybe you have another next hop in the path to reaching this next hop. This means that R1 you can choose every path after the 10133 to reaching to this path. This means that when R1 you reach to the router 3, okay, can use every path to reaching to this next hop because this is loose. Okay, and we didn't force, for example, one of these links, and this is the loose next hop. Means after that R3 can choose which path is the best path to reaching to the 192.168.2544. If both of for example these two paths are equal, the R3 can load balance between them. If one of them has the better cost, it can use that link, or for example maybe we have more than one link, we can use a structure about the, for example, load balancing or or fault tolerance between that routes. Okay, and after that here again we can configure the other next hop. According to this function we can configure two type of next hops in the explicit path. The first type of next hop is the strict next address or next hop. You know that until now we configured only a strict next hop. I will show you a strict next address. I will show you, but if you want you can configure the loose next address, and this means that It means that we can configure the explicit paths, and in some places we can use the loose option. This is the semi-dynamic. Why? Because here we are configuring explicit paths, but in some places in the path we are using the dynamic method to finding the best paths. Okay, let me to show you. After configuration we can better understand the concept of the semi-dynamic tunnel with loose next up. Look at here, this is the scenario we configured. The similar scenario in the previous videos. Let me to use the one of the CLIs that I have, one of the configuration file that I have, and after some change we can use this configuration file in this scenario. Let me start with the router one. Again, I'm configuring all of